Okay, I have 1:15. So we're recording this in case anybody is unable to attend but wants to watch it, or if you want to go back and watch it yourself. So I wanted to clarify first that the test next week, lecture exam 2, is going to be over chapters 5, 6, and 7. It will not include the joints chapter, which we're beginning this week. I think I probably made mention of the possibility of it being included on the test next week, but it's not, even though we're starting it in terms of the schedule.
So 5, 6, and 7, right?
Yes, 5, 6, and 7. 5 was tissues, 6 was integumentary system, and 7 was skeletal system.
That's the lab quiz. Lecture.
That's the lecture exam. Lecture exam next Wednesday in lab. Everybody clear on that? Worth 80 points, just like the first exam was worth 80. Multiple choice, matching, and probably your choice of a few essay questions. Any questions on that?
Like what kind of essay questions could be asked?
Well, you come up with some for me. What would be good essay questions for tissues, integumentary, skeletal?
I feel like the skeletal you'll ask about like ossification.
Right? Those could pertain to essay questions. General conceptual physiologic sort of topics are always good for essay. For integumentary system, I think there's a section there on skin cancer. That could be a good essay question. Right? What else would be good essay type questions? Healing of wounds. Different kinds of burns. Those would be good essay questions. For the tissues, it could be name 5 types of connective tissue and where you might find them in the body. Are there specific topics in chapters 5, 6, or 7 you'd like to review? It's been a while since we've talked about tissues.
I have a question. Can we go over the lab quiz 4 that we just had? Only because when you went over the correct answers, I didn't have a pen or a pencil to write with.
Sure. So you have it with you?
Yep.
Okay, so 1 was metatarsals,
Right.
2 was 24 and true, 3 was C, 4 was tubercle, 5 was A, 6 was E, 7 was dens or odontoid process. 8 was ilium, ischium, pubis. 9 was sternum. 10 was patella. And 11 was 56. 14 times 4.
Thank you.
Sure. Don't forget, there are some videos posted in the Blackboard course shell that cover the different types of ossification. Would be worth maybe looking at. I mean, I'm assuming you have looked at that, right? These two.
Yeah.
Mm-hmm. And then the other thing that I think I have mentioned before is Khan Academy has some excellent videos on almost any topic you're going to encounter in biology.
What was it called again, sir?
Khan Academy.
Okay.
Khan Academy. It's all free. They're really excellent. And as I think more about this, if you go to the course shell, in the content section, I thought there was there's a folder here called practice websites. Is it pulling up for you now or not, the Word document? Can't you see it?
It's spinning. It's trying.
Okay. I guess I got to reshare it. How about now?
Yep. Well, yeah. Yep. Is this
So-
in there also? I know there's one that's like physiology and anatomy videos, and it's like a whole page. You have the human experience one with the cadavers and stuff. Is this on that too?
Oh, well, you don't see that listed here, but I know what you're talking about.
Okay.
I would check out this one I've highlighted in yellow
Okay.
as well. I just remembered that. That's really, really good. Lots of good videos there. Khan Academy is not listed here. I should add it. What you were thinking about, I believe was under,
I think it's under those videos under content. Like there's just a bunch of them.
right. So right here, A&P videos. It's another Word document. I should just probably combine those. So there you see the Gunther von Hagens videos. These, I don't know if you've looked at any of these. They're creepy but interesting.
They're awesome. Oh my gosh.
Yeah, aren't they?
So when someone passes away, how do you donate your body to science?
Well, you could certainly contact, like your local funeral home director. They would have the information probably as to how that happens. Or you could contact UB Medical School. They could help you get the forms and that kind of thing, so it's all done. There certainly would be some paperwork to fill out, as opposed
Right.
to it happening and then your brother says, well, Freya told me yesterday when we were having dinner that she wants to donate her body to science.
Too late.
So too late. Yeah.
Okay.
It's kind of like the, you know, when you get your license, you can fill out the little section where it says, did I donate your body to science thing? Or it might be. I'm trying to remember. Like on your license. Don't they have that?
Yeah, that's an organ donor. I was thinking it was something different.
Yeah, you're right. That's organ donor.
Okay.
But this whole thing that Gunther has put together,
Yeah.
somehow he acquired these bodies, you know, of course, legally.
The right.
There apparently is an illegal similar project that somebody did in China. I heard through the grapevine.
Wow.
Where they took like prisoners and used their bodies. It's something really illicit and illegal and weird.
Oh my gosh.
This is all legit, but it's fascinating, just fascinating stuff.
I couldn't believe it. There's a pregnant woman.
Yeah.
And they did that section perfect because you can see just everything. I couldn't believe it.
Yep.
But,
yeah. Very interesting. So back to you know, Khan Academy. It's a really good site, and I'm sure you guys may know of other sites as well. And so if you come across something, let me know. We'll just add it to the list. All these things take time to go and watch and study and so forth. But for topics like endochondral and intramembranous ossification, that would be a very good place to go and just see what they've got for those two processes. Or really any of the topics I mentioned, you know, skin cancer. I mean, they're just lots of really excellent, well done, accurate, scholarly sorts of sites. Nobody has any questions? Nobody wants to go over anything? Everybody wants to go outside and have a picnic? It looks nice out.
Well, I mean, it's been a while since we went over tissues. If you just want to go over that, I guess.
What specifically?
Like epithelial, maybe.
Okay. Let's see, I did pull up the PowerPoint.
I know my biggest weakness with the epithelial is just deciphering them under the microscope, like the differences. So a review of that would be really helpful.
Okay. So I have the PowerPoints. I pulled them up. Why can't I see them when I share? Why aren't they here? I don't get it. All right. Well, we're going to have to try something else here. Are you seeing the tissue PowerPoint? It's not here yet, but it should be pulled up in about 8 seconds. Do you see it or not?
No.
I see your blackboard.
Okay, here we go. Now you see it, right?
Yes.
Okay. So let's start with the epithelial tissues. And this applies, of course, to all four groups in terms of understanding the different kinds, where you find them in the body and what they do, right? We've kind of used that same mantra, if you will, in lab, right? So studying for this in lab should help you in lecture and vice versa. So one thing that we said when we first started looking at this in lab is that when you go to define an epithelial tissue, you've got to have a free surface that the cells face. Usually that's a space. It could be an outside space, like say the skin is facing the room, or it could be the inside of your stomach or your small intestine where the food is being digested. That could be the space, the free surface where the food, if you will, comes into contact with the inner lining of the stomach. And then on the opposite end of the apical free surface would be the basement membrane or basement lamina that anchors that epithelial tissue to some underlying connective tissue. And I think everybody understands what this involves, because you all, when I ask you, you know where that basement lamina is, basement membrane, and where the free surface is, because there's usually some white space, facing that free surface. And what did I say to look for histologically? Paige, you could probably answer this. When you look at a slide of epithelial tissue, and I ask you, where's the basement membrane? What did we say was a good way to sort of visually find that? Remember?
It's usually like a straight line across the bottom, right? Is that what you mean?
Well, it might not be a straight line.
Like a solid darker line, is that?
Well, I don't even know that you can say it's a line necessarily, but
Well, I meant just a border.
When you see a distinct transition or change in the overall color or appearance of the tissue, that is often an indication where the basement lamina is.
Okay.
And I'll give you an example of that in a second. Okay. We also mentioned, and I remember writing this on the whiteboard in lab, that when you think of epithelia, which is the plural term for epithelium, there are different kinds of epithelia or epithelial tissues. We often categorize them based on two criteria, which you see here, shape of the cells and if there's layering of the cells. Now that doesn't describe every single kind of epithelium, but it covers a good 80% of them. What do I mean by that? I mean, you can combine the terms: simple squamous, simple cuboidal, simple columnar. There's three, right? Stratified squamous. There's even stratified cuboidal and stratified columnar. Now we crossed those off the list, off the table, if you recall. In fact, I probably have a slide up here that, there we go, there's the slide where I crossed those last two out here, right? But here's, the first five listed or so are just a combination of the shape and the layering ideas, right? So if you can understand the three basic shapes and conceptualize that those cells will either be in a single layer or in several layers, you're more than 50% of the way there, right? So let's talk about some of these different types of epithelial tissue, starting with simple squamous. Simple means one layer, squamous means flattened cells. And there you see sort of a three-dimensional or two-dimensional sketch the artist has done on the left. And then you have two stained histologic views on the right. The bottom right view is a section where we've cut right through this tissue, like we're looking at here. And this upper right-hand photograph is looking down from above, right? Like if we're looking, can I do this? Let's try this. I've never tried this before. I should. Yeah, it works. Can you see the red arrow? Yeah, so when you look down, that's what this is. When you look sideways, that's what this is.
I mean, are the cells always on a layer on the top? Because like on the one on the drawing or whatever, they're below. With
On
the
this
squat.
drawing,
Yeah, they don't look like they're like, looks like more than one layer, kind of.
yeah, but these aren't both epithelial. This is connective down here.
Oh, right. Okay, that was stupid.
Yeah. And
Sorry.
so no, that's okay. So the basement lamina or basement membrane is right there, that darker purple. Oops, hard to work with my mouse. Right? See it? Now it's easy to see on a labeled colored diagram. I mean, you got to be blind not to see that. But when you're looking at this lower right-hand corner, oh, how do I erase this? I'm not sure that I can. Then you say, oh gosh, where do I look? Well, I think everybody can see the simple squamous cells, can't you? Can you identify those? Yes? No? Maybe?
Yes.
Whoops, sorry. They're here, right? These are the simple squamous cells. And do you notice, like when we move from this free surface side, this is the free surface up here, right? This is the arrows pointing to the free surface side of the cells. Just like this is the free surface. When we go to the opposite end of the cell, and this is only one cell layer thick, so you don't have to go far, do you? Then we look for a gradual transition in overall appearance. So as I go down deeper into the tissue, boom, this suddenly looks different, doesn't it? Doesn't this look different than this looks? It just does, right? It looks very different. And so where you have that transition into difference, if you will, that's likely where that basement membrane is going to be. So if I wanted to highlight it, it's going to be right where I'm drawing with the green. It's going to be right there. It's the basement membrane. Of course, it's already labeled, but I didn't have to have that label there. You could have found it. And then by definition, anything deeper than the basement membrane, which is all this stuff down here by the X, that's connective tissue, right? And so simple meaning one layer thick, squamous flattened. This is the type of tissue that's going to be involved in things like diffusion. Hey, Steph. Yep. Okay, you guys, hang on one second. I have to do something. So just hang in there. Sorry, I wasn't quicker. No, that's okay. Actually, you can use the key, or it's got this ability. If you're within a foot of it, it just. Okay. Yep. But here's the unlock. You need it. Perfect. It's the black Telluride. Yeah. And so you'll see when you press the button.
How do you like it?
Oh, I love it. Yeah. It's nice. Yeah, it's nice. Okay. All right. Sorry about that. Do you see the simple squamous again now? Okay. So in terms of function, again, think diffusion, because for example, the simple squamous of the alveoli, those are the microscopic air sacs of the lungs. In fact, they tell us right here in this little insert sketch, lungs, diffusion of gases between the bloodstream and the lung tissue. If we had layers of cells here, that would impede the ability of the gas to diffuse as efficiently, but having a very flat, thin layer means that CO2 and oxygen can diffuse right across that much easier. So are we good with that one? Any questions on simple squamous? Simple cuboidal. What's there to say here other than instead of flattened cells, cube shaped? The histology is not that much different, right? Look at the sketch here. So in this right-hand histologic stained tissue, which looks quite similar to what you looked at when we did this a long time ago, it seems now, right? A couple months, not a couple months, but probably a month. These are cross sections through tubules, likely in the kidneys. And so this white space that you see here, which they have labeled as lumen, there's a lumen of this tubule in white here. Here's a kind of an oblong lumen. This is where the liquid is passing in the kidneys. And so the free surface is going to be that portion of the cells that faces the lumen. So this lumen is, as I said, containing a fluid, a liquid. So the free surface doesn't always have to face an airspace. It could face a place where there's liquid too. For example, if I said lumen of a blood vessel, what's inside the lumen of blood vessels?
Blood.
Right, blood cells. It's a liquid. And in that particular instance, we'd be talking about simple squamous, actually, lining blood vessel walls. I didn't mention that earlier, but that's what we have. So anyway, okay, hang on one second. Any problem?
None.
What's
that?
So, thank you, so I really appreciate that. It was really great to use that. I would have been.
Oh, yeah, that's very nice.
Thanks, Scott. So the basement membrane then would be on the opposite side of the cell. And again, if you want, we can get a ink pen here and we can find that. There it is. Comes around this way and that loops around. You can actually see it here though, can't you? If you look really close, you can see the basement membrane is the base of the cells. Oh, I did a nice job. That's really good. Where would it be down here on this tubule, the lower one? Can you find where the basement membrane would be? I think you can. Can you find it? It's going to be right here, isn't it? Oh, I can't blow it up and do it, but it's going to come around here. And then it's going to come back around here. And then it's going to come around here. Right? You're all frozen.
Where did he go?
I was wondering the same thing.
I think he was frozen.
Class dismissed.
Sweet. I wonder if we can use, so we can use this.
I think I was overtaxing the system. Because suddenly I looked and you were all like frozen. I don't know how far we got, but did you see me find the basement membrane of that tubule? Yeah, okay. Again, I don't mean to go super slow here. If I'm going too slow, just say, hey, I know that. Let's keep going faster. Tell me what you want. So functionally, think secretion for simple cuboidal. They do list here also absorption but I always think secretion. But in the case of the kidneys, not only do you produce urine, we all kind of know the kidneys do that for the most part, the kidneys also reabsorb extra fluid and put it back into the bloodstream. So that's what they mean by absorption. So it's a dual role. Sometimes there's absorption of liquids from the tubule, and sometimes there's secretion of liquids into the tubule. And that secretion into the tubules eventually becomes urine, basically. Okay, are we good with that one? Do you see simple columnar up on the screen next? Yes?
Mm-hmm.
Okay. So in this case, we said in some organs, it could have cilia on the surface, or it may lack cilia. The only places you would look for ciliated simple columnar would be those that are lining the oviducts or fallopian tubes in humans. And the cilia would be used for what purpose in that instance?
Move things along, or more surface
What
area.
do you mean, like things? You mean what are things?
Eggs.
Like only
Eggs, sorry, or like if you're menstruating, I guess I thought just, yeah, I guess it'd still be eggs.
Well, if you're menstruating, you're not.
Well, then you're shedding the lining.
You're not sloughing off the tissue of the fallopian tubes. You're sloughing off the tissue of the uterus.
Uterus. Oh, okay.
Right.
Yep.
Now, if I'm a sperm cell, why is the ciliary action kind of a pain for me?
What do you mean?
Okay, if we establish the fact that the cilia in the fallopian tubes is there to help propel the egg from the ovary
Right.
to the uterus, okay, where does most fertilization of the egg occur? Do you know? I know that we haven't done this system, so maybe I'm not asking a fair question, but I'm going to ask it anyway. Do you know where conception occurs most of the time?
Well, it's obviously not in the fallopian tubes because you can die from that. It's right past the cervix? I don't know.
No, it's in the fallopian tubes.
It is in the fallopian tubes.
Yeah.
Okay.
Yeah. No, if you have an ectopic pregnancy, that's a whole different situation. But
Okay.
typically the fertilization of the egg occurs in the fallopian tube. So
but it just doesn't attach to them though, right?
Exactly.
Okay.
It shouldn't attach. It does want to, unfortunately in some women, and then
I had that happen once. I lost it.
Yeah.
I had a tubal, yeah.
Yeah.
But I didn't realize that. Okay.
Yep. So back to my original comment, and which was why, if I'm a sperm cell, does this cause me issues? Well, I kind of answered that if you think about it. What do I have to do to find the egg? I have to swim against the ciliary action of the cells that line the fallopian tubes.
So it's only the strong sperm that make it.
Well, kind of.
Not really.
Well, yeah, you have to understand that half will swim up the wrong river. In other words, some will go up the left fallopian tube when the ovulation occurred in the right, and vice versa. You know what I'm saying? And some die on the way. And so of the 400 million sperm that are ejaculated on average, a couple, well, it depends on who you believe, but a couple tens of thousands reach the egg. It's a small percent of the total because of these different variables. Anyway, most simple columnar epithelia is non-ciliated. Okay, the only type that we know of are lining the fallopian tubes. So the non-ciliated simple columnar, when you think of that, you should think of uterus, stomach, small and large intestine. Here we're looking at the small intestine in the photograph and in the artist's sketch. And on the apical or free surface, we see microvilli, not to be confused with cilia. They're located in the same general region, which is the apical surface, but microvilli are there for what purpose?
Increased surface area,
Right, for optimal what?
absorption.
Right, absorption of nutrients. Exactly. And so on the right-hand side, I'm sorry, on this next slide, you can see a magnified view on the tip of a single simple columnar cell, and you can see these microvilli. Again, this is on the tip of one cell. Take a bunch of microscopic cells and do the math. We're talking a lot of microvilli. That's why you get the optimal absorption of nutrients. You could also argue optimal secretion of things like enzymes and other fluids. In fact, here's a cell devoted to secretion of a particular fluid. Goblet cells release mucus, right? So they're sort of embedded within these non-ciliated simple columnar cells. They're columnar, obviously, based on their shape. Here's the basement membrane in dark purple, and everything below that, connective tissue. In the diagram, or in the photograph rather, in the histologic section of the small intestine, which we see on the right, can you see the basement membrane area, or where the basement membrane should be? Again, it's labeled, but resist looking at the label. See if you can find it without looking at the label. How do I tell the difference? How do I know where to look for? Well, when you move down through the simple columnar cells and suddenly things change visually, boom, there's the basement membrane, right? So it's going to be what I'm outlining here in red. It comes up around like this, and then it loops around, and then it comes down like this. That's the basement membrane. Meaning that everything here is what? What kind of tissue is this? X's.
Connective tissue.
Right. Okay.
What part of your body is this coming
Small
from?
intestine.
Small
Right here.
intestines. Okay.
Right. Look at the
Oh, duh.
diagram. But the stomach would also have a similar histology. Only, yeah, they'd have microvilli there as well. For example, you know, alcohol is absorbed very quickly once you drink it. Doesn't take long. You feel that. You feel beer if you're especially on an empty stomach. That's because the alcohol gets absorbed in the stomach, by the stomach, which you know is before the small intestine, right? Yeah. So there's absorption. There's absorption going on in the stomach, not of a lot of organic compounds like what you had for lunch or breakfast. Most of that occurs in the small intestine, but alcohol is one example of a compound that is absorbed very quickly by the stomach. Are we good with this? Questions on simple columnar? Okay. Here's sort of a special category called pseudostratified epithelium, which is always ciliated and always columnar. So I group those words all together. Pseudostratified, ciliated, columnar. Let's dissect it. Columnar referring to the prominent shape of the cell present. Ciliated is obvious. What does pseudostratified mean? Look at the word.
It looks stratified, but it's not.
Right. It's falsely stratified. And when you look at this histologic section on the right-hand side, and you just look at it and you react to what you see, your gut says stratified, because you have some nuclei, for example, that are located very near the basement membrane, like these guys I'm circling in red, right? They're right next to the basement membrane, which is down here. But then I have some cells whose nuclei is midway or even perhaps higher up toward the apical surface end. So it almost looks like there could be a layer here and maybe another layer down below, doesn't it? When you just look at it and you just react to what you see. But the reality is all of these cells, even this one right here, will come down and touch the basement membrane. All of them. Not all will have a free surface. Most do, but not all. In fact, if this diagram shows it much better than the photograph. See how this cell here touches the basement membrane, but it doesn't have a free surface, and it stops kind of like right there. This guy stops kind of like right there. This guy stops kind of like right there. You see what I'm getting at? Most of the cells, more than 50% or 60%, they do come up and touch the surface. They have an apical surface end. So this is falsely stratified, and it tells us to look here in the respiratory tract. Specifically, I would say go to the trachea, and in some parts of the upper respiratory tree, if you will, where the trachea branches into what are called the primary bronchi. We'll get into this in another month or so when we do respiratory system. There's a very interesting change in histology when you go from the alveoli, which is simple squamous, and work your way up toward the trachea. You run into several different types of epithelial tissues. So are we good with this one? And then I think the last one we talked, well, not the last one. We're not quite at the end. Stratified squamous. What more can I say? When you see this, what should you immediately think of?
Skin.
Right, skin. So here's the basement membrane, way down here. Do you see how we transition into a very light stained zone? That tells me we're out of epithelium and we're into connective tissue. And then obviously the apical surface is this space at the very top of the tissue. And notice how these cells, as they go from the basement membrane toward the surface, which you know is a result of cell division taking place down here in the stratum basale layer, right, the deepest layer. Look how the cells change in shape. They become more and more what? As you move toward the surface, how would you describe their overall shape? That they
Elongated.
More well or more flattened, right?
Flattened, yeah.
Yeah. And so the stratum corneum layer is of course way out here. These are the cells that are dead by this point, and they just get sloughed off, but they're replaced, aren't they? Yeah. And then transitional, I think, was the last epithelium we talked about. And this was characterized by a change in overall appearance, depending upon whether there was pressure being placed on the epithelial tissue or not. If there isn't pressure being applied, then you can almost discern multiple layers of cells, right, in either the photograph or the sketch. But if there's urine, for example, in the bladder, or urine passing through the ureters from the kidneys to the bladder, or passing from the bladder out, parts of the urethra, then it's going to push down on these cells and cause them to become a little bit different shape, more squamous-like. I got to be careful. This isn't squamous epithelium. This is transitional, but these cells certainly look flattened, don't they? They look very different down here than they do up here, and that's based upon pressure. So how was that for a crash course in epithelial tissue? We said you did not have to worry about the different types of exocrine glands. You don't have to worry about the different categories that table 5.3 talks about, right? But you should know the difference between an exocrine gland and an endocrine gland. Anybody remember the difference between exocrine and endocrine?
Well, I don't know exactly, but exo would be like leave and endo would be come in, right? So would it have something to do? I mean, I can't put into words anymore.
So exocrine glands secrete their products into ducts,
Okay.
like say the salivary glands,
No.
while endocrine glands secrete their products into the bloodstream.
Okay. And then they would be taken out of the body via the
No,
bloodstream?
no, no,
No?
no, no. They would
Okay.
stay in. They would stay internal,
Okay.
but be taken to some target tissue.
Oh, okay. Okay.
Yeah. So most of the hormones that are produced by, let's say the pituitary gland, okay, that little pea-sized gland that fits in the hypophyseal fossa of the sphenoid. This is bringing back horrible memories, I know. That little piece-sized gland, as big as your thumbnail, boy oh boy, it secretes, as you're going to learn, lots of hormones, different kinds of hormones, critically important hormones. So if you have damage to the pituitary gland, it's not good. Of course, in order to damage that, you got to pretty much crush your skull. So you'd
Or like,
probably dead anyway.
or if you had like some kind of brain tumor or something, it could affect, right?
That's right. That's a good point. Yeah, exactly right. Yeah. Okay, how about other topics in chapter 5? Are you good with connective tissues, muscle? We didn't say a whole lot about nervous tissue. We did talk about a neuron, and we pointed out some different parts of the neuron. But you'll be getting into much more detail in terms of nervous tissue when you take A&P2. As I said, there's 2 chapters on the nervous system and then a 3rd chapter on special senses. So a lot of the book is devoted to nervous sorts of tissue. Guess I can't use that marker thing. That's what's causing me to, I think, get kicked off or something. So I don't know if you heard my question. Was there any other topics in chapter 5 that you wanted to look at?
I have the question on the lesson quiz. Number 2, the question about the tendon and ligament are both composed of which of the following type of connective tissue? I confused between the hyaline cartilage and the dense granular.
Which question was this, Myve, and what quiz?
The quiz number 2, the question 8.
Okay, lecture quiz 2?
Yes,
Okay, and question, which one again?
8.
8, gotcha. So the question is, tendons and ligaments are both composed of which of the following type of connective tissue? And the choices were areolar or loose, B was hyaline cartilage, C was elastic, D was dense regular, and E was adipose. So let's go to the let's go to that PowerPoint. And what did you put down, Myve? Did you put down cartilage?
Yeah.
Okay.
I confused between the dense granular and cartilage, and then I
Okay,
chose the wrong one.
okay, no, that's okay. So let's go down in the PowerPoint where we talk about the different kinds of connective tissue. So you should see the table 5.7. Do you see that?
Yeah.
Okay. So we list, of course, all the different kinds of connective tissues here and what they do and where they're found. And so here is the dense regular connective tissue right here, which we're saying composes tendons and ligaments. So that's where that question sort of came from. And if we go into the specific slide here, and here it is right here, we look at the histologic stained section on the right, and here's the artist sketch on the left. And with these wavy lines are the collagenous fibers that give tendons and ligaments their strong strength. That's why the surgeon today, when he went to cut through into the knee joint, he did not cut across the tendon. Do you remember what he said he was going to do? Do you remember? How did he cut that quadriceps tendon? He didn't cut it. He didn't cut it across and cut it off. He cut into it parallel, right? Yeah, because he didn't want to damage this tissue. It's very slow to repair itself. Somebody said something, but I couldn't understand them. I think it was Paige. Can you guys hear me?
Yeah.
Okay. So because of the lack of blood flow to dense regular connective tissues, a torn ligament or a torn tendon or a damaged tendon or ligament just takes forever to repair because there's not much vascularization of the tissue. There's not much blood supply going here. Now, maybe you said you put down hyaline cartilage. Well, hyaline cartilage is coming up next here somewhere. There it is. This doesn't connect bone to bone or muscle to bone. It can be found between bones. So in an example of the costal cartilage, you see it between the sternum and the rib. So it can be sandwiched sort of in between, but this is not there to provide a significant amount of connection because there's not much movement of the rib or much movement of the sternum like there is, let's say, at a tendon where you've got a muscle pulling and a bone on the opposite end of it. So hyaline cartilage, it's on the ends of long bones. It's part of many of our bones before they become ossified, right? In the endochondral ossification talks about the conversion of hyaline cartilage into bone. Where else can we find hyaline cartilage? Remember? Ends of long bones between the sternum and the vertebrae. The nose is made up of hyaline cartilage. The trachea is made up of hyaline cartilage. So, does that help answer your question?
Yeah, it means that like we cannot find the tendon and ligaments in the cartilage.
No.
No. Oh, okay.
Cartilage is a totally separate, different connective tissue than a tendon or a ligament is.
Yeah. Okay.
Yeah, tendon and ligaments are both made of this dense, regular connective tissue. Now, you might wonder what's the difference between dense regular and this other dense irregular. Well, I tell you right here, the difference is in dense regular, you have a very dense patterning of these collagen fibers. They're layered one against the other, right? Right on top of the other. They're packed in there super tight. And that's what you want for a tendon and a ligament because it gives you maximum strength. But in the dermis of the skin, we have a more haphazard arrangement of these collagenous fibers. And so we call it irregular. That's what that means, irregular, not densely packed in a layered arrangement, but more random, haphazardly scattered. It still provides support because it's collagen fibers. Remember, those are the strong ones. But it does indicate here the reason for that is to provide strong strength and tension in different directions within the dermis of the skin, as opposed to in, say, a tendon or ligament, you have a more directed strength, if you will, to the tissue. Here you've got a more random assortment of those fibers.
Yeah, I think I got it because I remember wrong between the dense irregular and dense regular, and I messed it up with the catalyst.
Okay,
Yeah.
Yeah.
Thank you.
Oh, sure. How about other topics, questions?
In the course shell, chapter 8 isn't in there yet for joints.
Oh,
I kept forgetting to say that. I was so confused.
well, thank you for telling me.
And then also, did you record last week's class? 'Cause I don't-
Well, hang on one second.
Sorry, I'm sorry.
You're saying that the chapter PowerPoint is not listed?
Like if you go all the way down to the bottom, it might be under the anatomy and physiology, but somewhere in there it only goes to chapters. Actually, no, it's underneath, I think, in the Zoom things, isn't it, guys? If you go into the Zoom folder with the Zoom recordings, go all the way to the bottom, and it only goes to 7.
Okay, you're talking about the Zoom recordings, not the chapter PowerPoint.
Right, I think.
Okay.
Right, Sadie?
Right, there's not a YouTube video for the joint.
Okay.
Right.
Okay. Thank you. Because I swore I freed up all the PowerPoints, the chapter PowerPoints, and so they're all there. That's what
Yeah.
That's what I thought you
Okay.
were talking about.
Yeah, no, it's just the ones. It's just the, the Zoom ones,
Yeah.
which I like to watch those over and over.
Well, absolutely. No.
I put them on before I go to sleep at night.
Oh my God, for you.
I fall asleep to you.
Oh man, you have nightmares. Thank you for telling me. Obviously, I want to know that. I'm not purposely trying to keep it from you. I just forgot to free it up, I think. So
It's crazy all the stuff that's on there, I mean, I find more all the time. Did it take you forever to build this all?
oh yeah.
I can't even.
Oh yeah, years. And that's why when the Jamestown faculty said, well, we want to use a common book between the campuses, I'm like, you want to use my book, go for it. I'm not using your book.
Right.
Not because your book's not good. They have a very good book. It's excellent.
Right.
But I put too much time and energy, blood, sweat, and tears into these PowerPoints. They have no concept.
No.
Of how much
The ones that are telling you what to do. Yeah, no idea. I'm sure. I mean, it's so deep. I mean, you have so many layers.
Yeah, exactly. So now I'm freeing up all of the Zoom recordings for all of the chapters. So you'll have them for the rest of the semester. Thank you for telling me. Please don't hesitate to ask or tell me, hey, you forgot to put this there. Yeah. Okay, should be all there now. Because my goal is to get these out, in plenty of time. That was what I wanted to do. And I know you guys do like to watch those, so I appreciate you taking the time to watch them. It's you always like to, you hate to watch yourself on TV or hear yourself talk. Oh my God, I hate that.
Well, and you must be so sick of doing that. But with these things, it's so neat because even if you've already watched it once or twice, I'll put it on while I'm cooking dinner and then stuff still sticks, even if I'm not sitting there taking notes. You know what I mean?
Sure.
It's so, yeah.
Yeah.
This is all like so new to me. My in school 20 years ago, I'm just struggling, but you've made it easier. Thank you.
Well, it's challenging. It's definitely challenging. I think as you get older, there's less acetylcholine to help connect those synapses or something. I don't know what it is. Any other topics, questions? Here comes the 2:15 train, right on time.
Could there be like a question on the test about like hair loss from like that one little
Yeah.
like clinical page?
Yeah, don't forget the clinical application boxes, right? There's a section in there, and that's what you're referring to, Sadie, I'm sure. The alopecia. Right. Yes, yes. Don't ignore those clinical application boxes. There's one also on acne, right? We didn't spend much time talking about acne. I think I mentioned it in the lecture, Zoom lecture, but we could spend an entire, probably an entire course, I guess, if you're a dermatologist, maybe you had to take lots of classes on those sorts of topics. And they're sprinkled throughout, there's the one on skin cancer. No, I did spend more
Yeah,
time
the
talking
burning
about
one.
that.
That's crazy.
Pardon me?
That one's crazy.
Yeah. It's something that we all should be acutely aware of. And that's why I do take the time to talk about the different kinds of skin cancer.
Well, indoor tanning came out when I was like, that age where you wanted to be tan. I tanned so much. This made me cry.
Yeah. Yeah.
So dangerous.
Well, it is. And tanning salons can say, well, we're using the UVA and the UVB lights, and we're safer than we were 30 years ago. I got some swampland in Florida I'll sell you if you'd like too.
Right.
It's one of those things. Customer beware. And they understand just, how much young people want to be tan. There is this.
They're marketing on it.
Oh,
Yeah.
it truly is. It's a marketing thing. I mean, look at spring break, right? Everybody's going down south. They want to party and tan. It's part of the ritual of, some would say, growing up in America.
They target that audience all the time. Those pens that people were smoking. Oh, they're not as bad as cigarettes. The kids had them in school and stuff, and then kids were dying.
Sure.
Same thing.
Vaping, yeah. But I can tell you that I can lecture on this, and I can show you pictures of, the kid looking at his grandmother or whatever. I don't know if it's his grandmother. Remember that picture I put in the PowerPoint? And that still doesn't scare people enough to not do it. So,
Same thing with smoking, though.
exactly. Yeah. Well, listen, I will stay in the Zoom room for another few minutes. I know, let's see, John and I were going to talk, and then Freya, you and I were going to talk, right?
Yep. So if you want to talk to John, you can talk to him first, or me. It doesn't matter.
No, I think I told John that we'd connect about 10 minutes after we were
Okay.
done. So,
Okay.
so maybe John, you pop back in like 2:40, something like that.
Okay.
How's that sound?
Okay.
Yep.
Cool. I won't be long.
Okay.
Okay.
2:30. Check at 2:30, John. If we're still talking, and then we'll figure it out.
Okay.
Okay.
Okay. Everybody else have a great weekend.
Bye, guys.
See you Wednesday.
Yep.
Okay.
Okay. All right. So as far as like the paper,
Hang
Yeah,
on
go
one
ahead.
sec. Hang on one second. I'm going to end this meeting so that the system can begin recording it, and then I'll pop back in.
okay.
Just hang on.
Okay.